characteristics. First characteristics of scalar product is the scalar product of two vector is equivalent to product of magnitude of vector with the magnitude of the component of the other vector in the direction of first. That means vector P dot vector Q is equal to P Q cos of theta. This is the first characteristics of scalar product. Second characteristics, that is scalar product obeys commutative law of vector multiplication. Vector P dot vector Q is equal to vector Q dot vector P. Third characteristics of scalar product is scalar product obeys distributive law of vector multiplication. Vector P dot vector Q plus vector R is equal to vector P dot vector Q plus vector P dot vector R. These characteristics is called as a distributive law of multiplication. Fourth characteristics, special cases of scalar product. According to our definition, vector P dot vector Q is equal to PQ cos theta. If the angle theta between two vectors P and vector Q is 0 degree, then we get product vector P dot vector Q is equal to magnitude of these two vectors, that means PQ. If the angle between these two vectors is 90 degree, then vector P dot vector Q is equal to 0. We know that cos of 90 is 0. If angle between two vectors is 180 degree, we know that cos of 180 degree is minus 1. Therefore, vector P dot vector Q is equal to minus PQ. Next characteristics, vector P dot vector Q, then vector P is equal to vector Q. Then, according to our definition, vector P dot vector Q is equal to vector P dot vector P, which is equal to P square or Q square. And today we are going to study next characteristics. Characteristics number 6. Characteristics number 6. Scalar product. Scalar product of vectors expressed scalar product of vectors expressed in terms of rectangular components. This is the characteristics number 6. If vector P we can express in a rectangular components, then rectangular components of vector P we can write as Px I cap plus Py j cap plus Pz k cap. Px I cap plus Py j cap plus Pz k cap. And vector Q in a rectangular components we can write as Qx I cap plus Qy j cap plus Qz k cap. equal to Px I cap plus Py j cap plus Pz k cap dot Qx I cap plus Qy j cap plus Qz k cap. Px I cap plus Py j cap plus Pz k cap are the rectangular components of vector P, and these Qx, Qy, Qz are the rectangular components of vector Q. I cap, j cap, k cap are the unit vectors of these rectangular components. Let's solve this multiplication. I cap first, Px I cap multiply by Qx I cap plus Qy j cap plus Qz k cap. Px I cap multiply with this total component of vector Q plus Py j cap multiply with Qx I cap plus Qy j cap plus Qz k cap plus Pz k cap multiply with Qx I cap plus Qy j cap plus Qz k cap. Now we have to multiply this Px I cap, this total bracket. So next vector P dot vector Q is equal to Px I cap multiply with Qx I cap. So we get Px Qx I cap dot I cap plus Px I cap multiply with Qy j cap. We get Px Qy in bracket I cap dot j cap plus Px Qz I cap dot k cap plus now second term Py j cap multiply with Qx I cap. So Py Qx j cap dot I cap plus Py multiply with second term Py Qy j cap dot j cap plus Py Qz j cap dot k cap plus Pz, now Pz Qx k cap dot I cap plus Pz Qy k cap dot j cap plus Pz Qz k cap dot k component. Then remember the sequence k cap dot I cap we have to write here as for sequence. We cannot write as an I cap dot k cap. K cap dot I cap, k cap dot j cap, k cap dot k cap. In the second term also j cap dot I cap. We have to write that sequence as per multiplication. Now in earlier characteristics we studied that I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1 and I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is equal to 0. So substitute these or we get here I cap dot I cap is equal to 1. Therefore vector p dot vector q is equal to px qx into 1 plus px qy I cap dot j cap is 0. That means this term, second term is 0 plus px qz I cap dot k cap again 0. So third term also 0 plus py qx j cap multiply with I cap. This term also we get 0 plus j cap dot j cap, that means once. Therefore we get here py qy plus j cap dot k cap. J cap dot k cap is 0. So here we get 0. Last term plus k cap dot I cap is 0. Therefore this term also 0 plus pz qy k cap dot j cap also 0. This term also 0 plus k cap dot k cap is 1. Therefore we get pz qz. So the scalar product vector p dot q we get the result as vector p dot vector q is equal to px qx plus py qy plus pz qz. So we get the scalar product in a rectangular components we can express as vector p dot vector q is equal to px qx plus py qy plus pz qz. Students, सेपरेटली ही जी काही कॅरेक्टरिस्टिक्स आपण लिहिलेली आहे ती सेपरेटली तुम्हाला एक्झामला प्रूव्ह करण्यासाठी सुद्धा विचारली जाते. सो मल्टिप्लिकेशन करताना सेपरेटली तुम्ही px I cap टोटल ब्रॅकेट लिहिला प्लस py j cap सेकंड ब्रॅकेट लिहिला आणि त्यानंतर तुम्ही मल्टिप्लिकेशन लिहित गेला तर ते सिम्पली तुम्हाला रिझल्ट जो आहे तो रिझल्ट मिळतो. अँड 2 मार्क्स साठी ही कॅरेक्टरिस्टिक जी आहे ती प्रूव्ह करण्यासाठी एक्झामला विचारली जाते. सो सिंपल आहे. वी कॅन एक्सप्रेस दिस स्केलर प्रोडक्ट इन अ rectangular component of the given two vectors vector p and vector q. And the last property of the scalar product is characteristics number 7 if vector a dot vector b is equal to vector a dot vector c, then then if vector A is not equal to 0, vector A is not equal to 0, then use it is not necessary, it is not necessary, if vector A is not equal to 0, then it is not necessary vector B is equal to vector C. This is the characteristics number 7 of a scalar product. So next point is scalar product कॅरेक्टरिस्टिक ज्या आहेत कॅरेक्टरिस्टिक 7 आपल्याला दिलेले आहेत आणि ह्या सगळ्या कॅरेक्टरिस्टिक ज्या आहेत इम्पॉर्टंट आहेत. ठीक आहे, एक्झामला तुम्हाला डिफाइन स्केलर प्रॉडक्ट अँड गिव इट्स 4 प्रॉपर्टीज अशा पद्धतीने क्वेश्चन जो आहे तो क्वेश्चन विचारला जाऊ शकतो. ठीक आहे, कॅरेक्टरिस्टिक समजलं विद्यार्थ्यांनो. सो नेक्स्ट पॉइंट इज वेक्टर प्रॉडक्ट और क्रॉस प्रॉडक्ट of two vectors. Vector product, or we also call it as a cross product. Vector product or cross product. Definition. If vector P and vector Q are two vectors, then we can write as a cross product or vector product between these two vectors as vector P cross vector Q is equal to P Q sin theta u cap r, and this total result or magnitude, vector magnitude, we can write as a vector r. This is the first case. Second, if vector S is equal to vector Q cross vector P is equal to QP sin theta into U cap S. Now see this formula, vector P vector Q. We show the multiplication between these two vectors with a cross symbol. We show the multiplication between these two vectors with a cross, therefore we call the product as a cross product. Therefore we call the product as a cross product, which is equal to PQ sin theta u cap r. So cross product between two vectors is defined as a vector, is defined as a vector of the magnitude of the product of two vectors and sine of an angle theta, smaller sine angle theta between these two vectors is called as a vector product. Again I repeat, the cross product or vector product of two vector is a vector of product of magnitude of two vector and smaller the sine of angle between these two vectors. This formula or this definition we can show by the diagram like this. If this is the vector P and another vector Q, vector P, vector Q, there is a small angle theta, then its vector product, then its product is shown by vector r. Vector product, that means a resultant of these two vectors, is shown by vector r, and this vector product having unit vector. This vector product having unit vector. We know that unit vector we represent by letter small letter u, and this is the resultant r. Therefore, we write here u cap r in the direction of r. Therefore, we write here u cap r. So, vector p cross product with a vector q, vector p dot vector q is vector r. Now, as shown in the diagram, vector r is perpendicular to the vector p, perpendicular to the plane of a vector p. So, the magnitude of this cross product we write as a p q sin theta u cap r. Now, if we multiply or if we take a product, cross product between vector q and vector p, this cross product we can write as a vector r is equal to vector p cross vector q. Vector p cross vector q. See the direction. Vector p cross vector q. Now, cross product between vector q with vector p. So, suppose this is the vector q and next vector p. Small angle is theta. Then its resultant is a vector s. The cross product of vector q, vector p is a vector s. Now, as shown in this diagram, vector s, direction of vector s is perpendicular to vector, perpendicular to plane of the vector q. This resultant vector s having a unit vector u cap, having a unit vector u cap, and its direction or unit vector along the direction of s. Therefore, we write here as a u cap s. We write as a u cap s. So, vector product between vector product of q with p, q cross vector p is equal to qp sin theta u cap s, u cap s. See the sequence. We multiply with taking the cross product vector p cross q. Therefore, we write as a pq sin theta. Vector q cross p. Therefore, we write as a qp. Here, we cannot write as a pq. The sequence is changed, direction is changed. So, while writing the cross product between two vectors, we have to take direction of these two vectors or multiplication of that vector. Now, here is u cap r. We know that u represent unit vector. So, along the direction of r, and this unit vector along the direction of s. Therefore, u cap r and u cap s are the unit vectors. Shows the direction of product vector. Shows the direction of product vector is given by u cap. Means this unit vector u cap r and u cap s shows the direction of the product vector as shown by u cap r, which is a unit vector perpendicular. This unit vector perpendicular to the plane containing two vectors is given by the right hand write cross product between two vectors using right hand screw rule. See this, u cap r, u cap s are these product of vectors are perpendicular to the plane of these two vectors, perpendicular to the plane of the vectors, and is given by the right hand screw rule. So see these two examples, we can write here as a vector r is equal to vector p cross vector q, and here is vector s is equal to vector q cross vector p. We read this vector product as a vector s is equal to vector q cross vector p. Remember student carefully, here we cannot read as vector q dot or vector q dot vector p. We read this result as vector s is equal to vector q cross vector p, and this multiplication gives the cross product between two vectors. So vector s is equal to vector q cross vector p, and here is vector r is equal to vector p cross vector q, and these u cap r and u cap s represent the direction of their product vector. Therefore we write here u cap r and u cap s. So this we write depending on right hand screw rule. So what is the right hand screw rule? We learned in a 10th or 9th standard, right hand screw rule. So statement of this right hand screw rule, statement: if the screw is rotated, if the screw is rotated in the direction from P to Q, in the direction from vector P to vector Q, in the direction from vector P to vector Q through a smaller angle theta, then the direction in which tip of the screw, tip of the screw advances in the direction of vector r. Tip of the screw advances in the direction of vector r, which is perpendicular to the plane of vector p and vector q. This is the right hand screw rule, and using this right hand screw rule, we write the product between these two vectors. So up to this point we stop for today. Characteristics will take in the next lecture. Okay, thank you.